Hey class, this is Mr. Weckesser. I am here to talk to you about how to solve systems by using algebra. Yesterday we did solving systems by using by graphing, and now we're going to solve it by using algebra. Algebra just means we're going to do something that is, sorry about this, I'm trying to use this screen system for the first time. Come on, how do you get this to come up? Ooh, that's what I want. Number 2, chapter 3, 3-2 homework or notes. There we go. Perfect. Okay. So now we're going to do 3-2 solving systems algebraically. And algebra means for this, actually, we're going to add or subtract the actual graphs. Or instead of saying the word graph, we could say the systems, or we could say the y equals mx plus b format, which we're going to change into doing this into the standard format of ax plus by equals c, which is a standard, which we can then add or subtract into getting rid of variables to solve. And so we're going to talk about this, and it sounds confusing, but it's actually really, really cool. It's one of the coolest things that I like to teach throughout the year. So first we're going to talk about standard form. And I just said it before up there. Standard form is ax plus by equals c. That's standard form right here. Okay, we used to put point slope form, which is this. Okay, we still have the x, we still have the b, we still have the y, right? But we have the c too, and we have to worry about everything else. So circle the equations that are in standard form, and this looks just like it. You have ax plus by equals c. It's all right there for you. So yes, this is it. Let's zoom in a little bit here so we can see it. There we go. A little better. Next one is not in standard form. This is point slope form. So that's not standard form. This one is not standard form either because the y has to be on this side. And you can see the y on this side. And this one is standard form because we have the ax plus by equals the c. Even though the c is 0 here, it's still standard form. So it's a very, very easy concept. As long as you know standard form is right here, the information has to look exactly the same. Okay, number 2, write an equation in standard form. So you're using the point slope form. You're going to change it to standard form. So you need to get the ax on the side, or the 5x, and be next to the by. You keep the c over there, right? So how do we do that? Well, we're going to subtract 5x from each side. Okay, so you have 5x minus y equals 3. And I kind of skipped a step there because if you subtract 5x from each side, you have negative 5x plus y equals negative 3. And that's also correct. The book has this one. But if you just subtracted 5x, you would have this. So it's the exact same. If you look at all these, they're the exact opposite operation. Negative 5 right here to positive 5, plus y to negative y, negative 3 to positive 3. Number 3, we're going to change this also to standard form, and we're going to get the y, right? Here's the c by itself. Here's the x by itself. You need a y on this side. So let's change the y to that side by subtracting y from each side. So you have negative 4 equals, right, 6x minus y. But we can't keep it that way because we need this to be on this side. So we're going to flip the equation around. We're just going to flip it. And you're allowed to flip it. So you have 6x, right? Ax, right? Minus y plus by equals c. And your c here is -4. And so that's your answer. Number 4, it should be very close. All we have to do is get rid of the 12, right? This is the c, and we need to flip these two. So let's just flip those two first. You have 3x minus y. Then you're going to add 12 to each side equals 12. And that's your answer. So as long as it looks like that, you're fine. So here's what I talked about yesterday a little bit. 2, 1 is a solution of y equals 3x minus 5 because, and this is they're inserting the numbers in to see if they work. So you're going to insert those in back into y equals mx plus b, the solutions, to see if they work. So 6 minus 5 is 1. So you're going to insert them back in. So the solutions get plugged back in. You can plug them back in, right? And we did this before. It's called checking your work, right? Just plug in the solutions into the original equation. So main idea. The solution is the main idea. If two numbers are substituted for x and y in a system of equations and they make both equations true, then the ordered pair xy is a solution of the system. And so when we learned about graphing, we learned they were true if the graphs touched, right? That is a solution right there, right? They have one solution. If they were parallel, they had no solutions because they didn't touch. There's nothing to solve the problem. You can't solve the problem because they're never going to touch. And then if you had two lines that were exactly the same on top of each other, right? You have infinite solutions. And you can also write infinite using the infinity sign like that, which is pretty sweet. Use your vocabulary. Write 3 ordered pairs that are solutions of the equation y equals -5x minus 2, right? So write 3 ordered pairs that are solutions. So how do we do this? What are we going to do? Well, we taught you a long time ago to plug in, make a graph, right? The xy graph. Plug in things for x, and you'll get y. So we've taught you before, -2, -1, 0, 1, and 2. Plug them in for x, you get a solution for y. So you plug in -2 here, and you get -2 times -5 is +10. 10 minus 2 is 8. Put a -1 here. -1 times -5 is 5. 5 minus 2 is 3. Put in 0 here. 0 times 5 is 0, minus 2 is -2. Plug in 1 here, right? 1 times 5 is -5, minus 2 is -7. And plug in 2 here, and you get 2 times 5 is -10. -10 minus 2 is -12. So you kind of see a pattern here. Every time, you're getting 5 bigger. So we know we did it right. So your slope here is going to be, it looks like it's going to be 5. And it's correct because here's your 5. It's -5, actually. It's going down by 5. So we can plug in any of those 3 things we just solved for. So let's just plug in the first 3. -2 and 8. We have -1 and 3. -1 and 3. And 0, -2 are your 3 solutions. Okay. Down, use this system at the right and write true or false, T for true, or F for false for each of these. So here's your system. The system has a unique solution, right? Well, how do we know if it has a unique solution or not? We need to graph those or not graph those. So this is going to be false, actually. It doesn't have a unique solution. And I'll tell you in a second about that. The system has infinite many solutions, right? Infinity. That means it's the same line. And that's actually false too. Number 8, the system has no solution, and this is true. It has no solution. When it has no solution, it means the lines are going to be parallel. Okay, why are they parallel? Let's try to figure this out first. Okay, so we need to put them into, we have them in this format right here, right? We need to put them into a format that you can see if they're parallel. So let's put them back in the point slope. So the bottom one, you're going to have minus 4x in each side. So y equals minus 4x plus 2. The top one, right, it's a fraction here. And you can't have a fraction when you do these. So that's not standard form because it has a fraction. So you're going to multiply this entire thing by 2 to get rid of that fraction. If you multiply the entire thing by 2, you actually get 4x plus y equals 6. And then you minus 4x from each side. And your answer is y equals negative 4x, right, plus 6. And they have the same slope, right? So it has the same slope, so you know it's parallel. We could have done this first and figured all this out, but we did it second just to see how it worked out. Number 9, the solution is 0, 0. We know that's false because there is no solution because they are parallel, no solutions. Number 10, the solution of a system can be found by graphing the equations of the system. And that is true. You can graph them, right? And in a second, I'm going to show you how to do it a different way. Try to zoom this in a little bit here. Number 1, problem, solving by substitution. And with this, we have substitution, and you're going to substitute a number in. And my favorite is called elimination. And so we're going to stop here, and you have 2 things, substitution and elimination. And I'm going to teach you each of those, but on 2 different videos to make sure you understand those videos.